Ozone is a colorless, chemically active gas. Near the Earth's surface, high ozone concentration could cause rubber to crack, hurt plant life, and damage people's lung tissues. But at the stratosphere, a tenuous layer of ozone gas absorbs UV light, protect living things below. However, this good ozone layer was gradually decreased since 1970s because of human activity, and the ozone hole started to appear over Antarctica. If we look at the seasonal pattern of the global ozone distribution, we could find that ozone hole is most significant during the early spring over the Antarctica. So why? Why would ozone hole would appear over Antarctica in the springtime? Basically, it is because of the meteorological and chemical unique condition in Antarctica area. Firstly, in the winter, low temperature at the Antarctica stratosphere are important because they allow liquid and solid polar stratospheric clouds to form. PSC is usually formed by water and hydrogen nitrate at temperature lower than 197 Kelvin. At the surface of the PSC, heterogeneous reaction would convert chloride reversal species back to chloride and accumulate in the whole wintertime. Also, the hydrogen nitrate would be removed by gravity, and thus the concentration of the atmospheric NOx would be significantly decreased. The Antarctica temperature would also remain below the PSC formation temperature for a long period during the wintertime. It would remain for about 5 months. Secondly, the Antarctica stratosphere is relatively isolated during the winter season because of the adherence of polar vortex. The polar vortex is provided by strong circulated winds above the polar, and this circulation isolates the stratosphere of Antarctica from other parts, thus prevents the transport of ozone and NOx in or the accumulated chloride out. Also, this circulation strengthens as the temperature decreases. So, again, the low temperature play an important role in the isolation. When the spring comes, the accumulated chloride would then photolysis to form chloride radical, start to catalytically destroy ozone, and initiate the formation of ozone hole. Also, since most of the NOx is removed from the stratosphere, this process would not be weakened by radical reaction with NOx until later spring, and after that time, NOx transported in shut down the cycle, makes the chloride radical back to reverse species, and stops the growth of ozone hole. So, the ozone hole would be most significant after cold Antarctica winter in our Earth. If we look directly at the maps of ozone hole, low temperature area, and the polar vortex, we could find that there is a strong correlation of these three areas. They are basically happen in the same place, which could support that the polar vortex enhanced the formation of ozone hole. Also, the low temperature in Antarctica stratosphere allows the appearance of PSC forms from June to October, and the ozone hole above Antarctica area start to form in the beginning of August, just after the coldest season, which means PSC do play a key role in the formation of ozone hole. So, here comes to the conclusion. The low temperature in Antarctica winter allows the formation and remain of PSCs for a long time. Thus, the chloride will be accumulated until springtime. Secondly, the polar vortex isolates Antarctica area and prevents transportation and mixing. So, when the spring comes, the accumulated chloride would convert to radicals and catalytically destroy the ozone. Thus, the ozone hole would be formed in early spring over Antarctica area.